And here I am, and the stream works. Let me check if the audio works. Still a bit of delay, I have to wait 10 seconds. Yeah, okay. On the audio there's a ringing, and I have to find a way to remove this ringing with a low pass filter or something like that. Yeah, but for now you'll have to bear with it. Yeah, I'll check that later. I have no idea where the ring comes from. If it's from the cable, from the output, from the noise gate. At least there's kind of a noise gate, so you don't hear the ringing all the time, or you don't hear the noise all the time. But the audio works. And let's come back to the stream. And again, we are continuing on the design quest for the IOVoodoo. What we did last time was the board schematic. No, board schematic is done. What it did last time was the routing. So we did the placement of the parts. I showed you how I placed my parts. We started doing the routing, and now the routing is actually done. So board layout is kind of done. Never completely perfect, but for now it is done. And it looks like this on the screen. So let me put the schematic on the right. Schematic.pdf. This way we always have the schematic on the side and check for the schematic. And actually we don't need this anymore. So today we will do key ordering. Yeah, it's not as easy ordering to do. It's not as straightforward. There's more behind ordering than that you might expect, but you will see what is behind ordering. So let's come back to the routing. This is the routing which is done again using the EDA software PCB R&D. And if we look at the ruts, let's open the Windows log. Windows log, and now if I look for all ruts nests, connect ruts nest, optimize ruts nest, you see the layout is complete, no shorter nets, and there's no shorter nets. So all the signals have been routed. What is very important, so this is the first thing you have to complete somehow. Whenever you're routing, you are stretching for this goal, having everything routed. Once you have that, there is another important part with Jira, which is sometimes overlooked, but shouldn't, because it is really vital. And it is the DRC checks. DRC stands for Digital Design Rule Checks. And this actually defines how close you want to do. For example, let's check the rule check from, again, just JLC PCB, because the rules are well listed. jlcpcb.com. Oh, I know how to find them. Capabilities, so I have a couple of clicks. And here you see the PCB specification, so we can close this. And what is important, for example, the drill hole size, minimum drill hole size 0.3 millimeter. Well, yeah, minimum drill hole size 0.3 millimeters. And then the minimal via diameter is 0.4 millimeter. That's weird. This is weird. Minimum via diameter, because when you look a bit below, where did I see it? Annular ring. Minimum, okay, there's something weird, because the minimum annular ring is 13 millimeter. So 13 millimeter is one side. Since we have two sides, we multiply by 2. It's 24 millimeters, the minimum. And then if you add the minimum of 24 millimeters to here, the minimum via hole size, which is 0.3 for 2-layer boards, you are at 0.25 millimeters, 0.58 millimeters. or 56 millimeters, above 0.5. And here it says minimum drill 0.4. So, and then for double-sided it's 0.6. Ah, there it is, 0.6. So it makes now sense. And I don't remember if I have 0.6, so I should have read. So let's check actually. These are, for example, two things which are there, but there are lots of other parts. The clearance between two patterns, for example, the clearance between two wires, the minimum trace width, the minimum distance between, minimum spacing between traces. All of these things, these are part of specification. If you don't respect that, it might not be manufacturable. So this is why you have to specify them in the program preferences, size and DRC query. Now, PCB-R&D has a very, very powerful DRC machine because you can make your own queries. I'm not using it though, that powerful. I'm just doing the standard checks. For example, what it could also do, what I didn't program, and I'm probably what panelization. Things like that. Where is it by? Somewhere VGroove. Yeah, minimum edge. Okay, it's not only there. I did order some boards where I did some V-grooving, and actually you cannot V-groove very small PCBs. It has to be at least 3 millimeters thick PCB spacing, board outlines, and it's not written there. So this is, again, something which is not specified, but the support contacted me because they were not able to route to do some V-grooving because the space between the V-groove was less than 3 centimeters. This is something which is very hard to add into the DRCs, but in PCB-R&D, because of its query capabilities, you can actually add that, and you can say every line which is in the outline and not intersecting another should be at least 3 centimeters apart. This is something you could add. I didn't add it because I'm too lazy and there's nothing like that, but lots of these things like the solder mask and so on, you could actually specify, or the solder opening, things like that. We will just use the very common one. So file preferences, DRC, and in the DRC we look at the query, hole diameter, definitions, minimum gap. Here. Minimum drill, that's 0.3 millimeters, that's okay. Minimum ring, that's 0.13 millimeter, that's okay. But that's actually not correct because I should have a minimum via diameter and not just minimum ring. That would be correct. I could add a definition with minimum via diameter and then it could correspond. But now what we will do is have a minimum drill of 0.15, apply, close, and this makes 0.6 because minimum ring 0.15 millimeters times 2 is 0.3 plus the minimum drill 0.3, then it should be fine. What else? The definitions, the copper clearance, so that's clearance between traces, 6 millimeter. Copper overlap, how much of copper needs to touch the other copper to form a trace, 6 mils. Minimum drill we have. Overlap factor, I don't use it. Copper thickness 6 millimeter, that's the trace width, and seal screen is also 6 mils, not millimeters, 6 mils. And this is defined. Solder mask, for example, if we look at solder mask, no, not solder mask, legend, they call it legend, but it's the seal screen. You see the minimum is 6 millimeters. But for example, pad to seal screen, this minimum, this you could add a rule in PCB-R&D checking for that, and I'm pretty sure that some of my distances between pad and seal screen is not 0.15. It will still be okay during production, during manufacturing. Pad, yeah. This because it's vias, we don't really care with vias. So I could expand it. It's just a prototype. It's nothing which is for production. If I would do a production board, I would try to add all of these specifications. The pain there is also, these are the specifications for JLC PCB. Ausspark has other specifications. PCBWay has other specifications. Every manufacturing house, board manufacturing house, has its own specification. You could use the least denominator, so you can produce on all of them, or you can specify, or you already know which production house will be, and then you stick to theirs. It really depends. And as I said, not everyone specifies everything. They specify a lot of things because they get lots of questions probably, but even the panelization and the V-grooving, V-scoring is not specified. That it's minimum 3 centimeters. Is it here? Maybe it's in routing, minimum trace, minimum clearance, another ring, minimum rectangle hole. Maybe they've added here. Diameter, no pattern, drill size, thickness, tolerance, minimum dimensions, max dimensions. Okay, that's the max dimensions, but they have no, for V grooving they didn't specify that it's 3 centimeters. Maybe it changed at the time I've ordered. It was 3 centimeters, and they say they couldn't produce my board because of the V scoring or V grooving. So we've added that. Let's check DRC check and verify if everything is okay. Refresh, everything looks fine. Probably because these minimum vias, which were actually wrong when I drew it, last time we see, I fixed it. So if we edit the pad stack for the vias, we see that it is open. I forgot to open it. Edit. Here we have 0.3 millimeters hole and 0.6 millimeters top copper. So it's fine. But for example, let's just check something like if I add a trace here next to this via, will it complain? Yes, it does complain. It says the net is too close to the other one because we need a minimum of 6 mils, and actually we would need more than 6 mils depending on your specifications. Now normally it's also a minimum of 0.15 millimeters between the vias or pads and the seal screen. Here I don't respect it. I have less than 0.15. I don't really care because it's a via. I would care if it's on the pads. Here I don't have less than 0.15 on the pads. I have enough space. So I think we're fine. But I should create a DRC rule and write a DRC rule for that. For now, let's leave it open. All the DRC is passing, meaning this board is okay. And this is after routing, so you check all is routed and then it respects the DRC. But we are not complete. After that, we still need to do a couple of other things. It's verify the output. So for example, we have this. Now what we can, and on the back side, this you didn't see. On the back side, let's remove this. On the back side, I have added text to show the limits, what the board is about, the limits of the voltages and the currents, some information about the drive modes. Here, this is my open source hardware logo. You can find it out ohsv logo.ivoodoo.info, and you can generate your own. I'll show you. ohsv.logo. No. logo.ivoodoo.info. Yeah, you can generate your own and then export it to favorites thing. I don't think, but all should work. For example, I know Eagle has a new format. I still hope that they support the legacy one, and KiCad has also a new format. I still think they support the legacy because they have all of them. But once you've created your logo, you can paste it to copper or the seal screen as you wish. And this is my open source hardware logo. Then some information about some website where you can find more information. This doesn't exist. Don't go in there yet. It's not a production thing yet. It's a prototype for me. Once I will be in production and give it to other people, then the site will be there. And some credentials. And here, version, revision, and date, this will be generated automatically. It will not stay like this. And here's some information on the back of the device. So we know what the purpose of the device is, what the capabilities are, and what the limits are. Very important. So top, we don't want to do this. So we've generated this. What we need to figure out, what we need to check, for example, is the solder mask. Is the solder mask open on all of the pads? If you look at here, yes, it is open on all the pads, and the opening seems fine. We even have some closing between the pads, which is quite good for soldering. And also, I did open all my vias. You see, all the vias here, they are open. So they are not tented, they are untented. And here it doesn't respect also. Here also it doesn't respect, but I don't really, I could fix it though a tiny bit. Yeah, let's fix it. So it's this is still readable. Up, now it is readable. Here it's not completely correct. Let's try to fix it a bit. Up. And yeah, that's a bit better. It's still not complying to the specifications, but it won't be an issue because we don't solder on it. We will only solder to debug. And I could change the pad stack to have them tented. I don't want them tented. Let's see if they are able to do that or if they will complain. They meaning the fab house. I will select. So this looks nice, and we can check also the bottom mask. Let's switch the order. This is the bottom mask. It looks also nice. All the holes have solder opening. That's okay. And for example, what I did pay attention here, you see there's no text over the holes, almost no. So there's just a tiny bit. This is because they are open. If they would be tented, I would have no issue writing on top of here. Here I did put a bit of attention because they are open, so there is no solder mask, and without solder mask it's hard to have silk screen really printed on it. And generally they are here. For example, there's an issue. We have, I don't know if they will leave it this way. We can edit the text and add some spaces even more. Edit texts. This way. Now it's too much. Okay, now this is fixed. We also have no text on the thing. Here we have some text. I don't care. It should be fine. I could add some space here, but meh. They will probably just remove it. It's still it's still readable. What else? So this the first thing. After the solder mask, you have to check for the solder paste. Although for this board, we don't really need to check for the solder paste because we will not order a solder stencil and we will not do reflow soldering on an oven. But for example, I see a mistake here. This test point should, well, why not? Should not have solder paste. It will go through hassle. Here we won't solder anything on this test point. Can I remove it easily? Edit properties. No, that's not that. Let's remove solder now. Why can't I edit it? Why can't I select it? Here am I on the wrong side? Why? It tries. Edit pad stack. Edit pad stack prototype. And here solder paste we can deactivate top paste. And normally if I look at the paste, top paste, it is still there. Edit pad stack prototype. Visible, visible, okay. That's the current. Let's edit it. Top paste. Change, delete. Close. Now we have no opening for the top paste. Close, close, and if we look at top paste, yeah, there is no opening for the top paste. That's good. This is a test point. There is no paste on test points. And also on through hole, there is no paste because, well, it's through hole, you have to solder it. Although there are some kind of exemptions. For example, on these through holes, the connector can be surface mount soldered and you don't have to solder the through hole. You can have, I think it's paste in hole. So I could specify here, add an put an opening. This way there will be some solder paste put in here, and when the connector gets there it will be soldered, and it's good enough, and you can solder it this way. It's still better to solder it by hand with the soldering iron, any kind of through-hole components, but it does work with soldering paste for this connector, and it is also meant to be this way. So I could edit this pad stack and say, here you will also add some paste, so I can just do surface mounts for this connector. We don't care in our case because we will solder everything by hand, and this will be soldered here. But for the production one, I will probably, if I keep the same thing, I will edit it and add an opening here, so solder paste flows here. And these are things you have to check afterwards, and if you just do the layout, these are things you don't see immediately. If you just look at deck and the tracers, it's nothing there. So don't forget, look at the solder mask, look at the seal screen, solder paste. Then if this is done, the outline is okay, and you are probably wondering what this is. This is a breakout board. Let me show you why. Yeah, so I need to find probes JTAG. Yeah. Switch on the camera. Camera on. We will have a connector like this. This is an IDC 20-pin connector. The issue is that you want to connect it. You want to connect it to the target board. And this means that you need some DuPont wires to the target board. This is not always the case. Sometimes you just have flying leads to the target board. You don't have DuPont cables or IDC cables. So what exists is that you can have, for example, like this is a good idea actually they have. Here you have the headers, so you can make DuPont, you can put the DuPont connectors here and connect here, but you also have some screw terminals. And this allows you to put a cable inside and then screw it. The issue is that you have to screw it, and I didn't like it. So the idea I came to is having also terminals, but having kind of quick connect terminals. And I found these ones. Let me get them out of the box. These terminals. You have to press either with a screwdriver, there's a slot inside, or just by hand with a finger. You have to press on it, and then you can put the cable and if you release, it holds really tightly the cable. And this will allow me to connect just flying wires to the test board. And that's why I have, so these are my connectors. There are various kinds of connectors. You can screw them. I also have these ones where you have to press hard on them, but I don't really like them. And I find pressing on them is hard, but there are plenty of connectors. And this is, so let's switch off the arm cam. And this is what this board is about. Here you connect to the, oh, I can enable the camera again because I want to show you something else. So here you connect the IOVoodoo, and here on the right there are the connectors, these connectors where you just have to push on the lever and then you can put the connectors on here. And it's just a breakout board. What's also important is that often you have to connect multiple ground points or multiple 5-volt points. And this is what we have here. We have 2 ground points, 2 voltage target points, 3 volt and 5 volt and 3.3 volt points. This is if you want to connect more power pins, or if you want to use the DuPont cable for the power pins. And arm cam. And then here we have the Logic 16 logic analyzer. This is this one. So it says Sealy Logic 16. That's not a Sealy Logic. It's a knockoff, or at least it uses the same principle as the Logic 16. And I use it with SIGROC, and SIGROC works perfectly fine with that. I don't know if it's still supported by Logic 16. I think so. But Logic 16 has now the Pro version, which is, sure, it is better. It's more expensive. I have this one for a long time. And this allows me for having 100 megahertz on 16 channels. And here is the pinout. And I just respect this pinout, so I can connect the logic analyzer directly to this breakout board and listen to the signals and debug the signals. If it's a protocol I don't know or I don't support yet, then I can still connect the logic analyzer and have the logic analyzer decipher the connections, decipher the decode or parse the communication. And same way, instead of the logic analyzer, you can just plug a microcontroller and talk, I don't know, but this is not the point microcontroller, because here we have a microcontroller which does all the work. Now, you would think this is a two-part design. It is still part of the IOVoodoo. This is, you connect this cable, this part here with an IDC cable, 20-pin IDC cable. They are quite common. Something like this. Here we have, oh, this is also a breakout board, which is very useful. This you connect to the J-Link or any kind of ARM, any kind of adapter which has the ARM pinout, which is this pinout, ARM debug pinout. Or you connect directly using this thing, and then you break out with many of other connections, because this is the ARM format, but you have plenty of other JTAG connection ways to connect JTAG. And actually I could also add this connector to my design, but I don't think it is really necessary. If I have the breakout board, I will use these ribbon cables to put it next to the target. So yeah, I will not put this connector. Although, will I? Don't I? No, I won't. Just use the cable. And this allows me to get further on. If you do, you can make these cables really short, so that's good enough. But this is it is kind of a separate board, and this is why you can also see that we have 2 different ground planes. But I want to produce it in the same batch, and this is where it will get a bit annoying, and we will see if it works or not. So I only have one outline, and the outline covers the 2 boards. So this cyan color here, this is the outline of the board. And you see that to fit the outline of the breakout board, I also removed the PCB under the connector, which is fine. The connector is holding tightly because we have 20 pins, through-hole pins soldered there. So I have no issue having no support under the connector, under actually the housing of the connector. And now we have one outline, but we have a separated ground. Ideally, what you would do is have them completely separately routed. This way you have a very nice separation between both because they're separately routed. But for that you have to make two orders and two productions, which is why not fine, would be fine. I wanted kind of to cheat and see if it works to have them on the same panel. So the alternative is like you would make panels, you can panelize yourself, but you have to pay some additional fees. If you want to make panels, let me show you JLC PCB, a quote now, and this doesn't work. JavaScript. Here I will have, if it's two different design, you see the calculated price is already really high because there's engineering fee and so on. There's a panel fee and there's a board fee. If there's only one, then you have this special offer for $2. As soon as you go to different design, you are really increasing the thing. So what we try to do, panel by customer, yeah. What we'll try to do is having a single design, and then we want a single PCB. We don't want a panel, because the panel, again, you add some cost. Instead of having the $2, you have the $4. You have minimum $8 if you want to make the panels yourself. So this is why we are well, it's cheating or not really, because it's part of the same design. It's just this connects here. It's a two-part design, like this. But ideally, you would completely route them separately. So you have two different designs, what they call designs on the manufacturing side, or you have one design with two boards, and then you add a routing here, like you would make for a panel. If you don't route, you can also have a V-score, where you just have a line which V-scores, and then you can snap off the two devices. But they consider the V-score also as having kind of a panel. So previously on JLC, you could put whatever you want in 10 by 10 millimeters. You could make your panels yourself. You didn't have to pay anything. As long as it was 10 by 10, you could add it. And for $2 or $4, you had 10 boards. Now it changes. For $2, you have 5 boards, and you cannot make panels yourself. Well, you can make panels, but you have to pay for the panels, because previously anything you put in 10 by 10 would have worked. Now it doesn't work this way. And this is why I didn't add any V groove and so on. If I do production, I will have V scoring to have the separate board. For now, I just have the separate boards, and I will just cut myself this using a cutter or a guillotine, paper guillotine. You can cut the boards and separate them. This is also why I separate the two grounds. And we will try it this way. We will see if JLC will complain and say, you have two designs because you have separate ground planes, for example. I don't know if they will say it's a two-part. It's one design in two parts. Let's see if it passes through or not, and if they allow us to do it. We'll see. So this is the last addition. I've added the breakout board. I could order it separately also, but it is kind of part of this. I will always provide a breakout board with this thing, so it's a two-part design. Let's see if it works, and if JLC, PCB, or any fabrication house will allow us to do that. Once you did that, so once you did these verifications with the routing, the DRC, routing means no net list is colliding and everything is routed, then the DRC to check if it specifies the rules, then you have to check for solder paste, seal screen, which the DRC cannot do, and top soldering mask, a DRC cannot do. This is just human. Then you are almost finished. is not finished yet. So let's save this. And what you also have to do is check the output. Very important to check the output. I'll just make rake, and my scripts, this is also why I like PCBRNT, just generates everything out of the schematic and out of the board layout. So it takes a bit of time because it generates some outputs, also some photo outputs, and this will allow us watching how it looks like. So they're still generating. Let me push on this. So what you're hearing in the background is my laser printer, which is getting warm, and I need to enable the printing service. Here generates the other side. The photo render is a bit slow because we have a high DPI, but we're not generating the outputs every 5 minutes. So if we generate it every half an hour and just have to wait 1 minute, it's perfectly fine. Even if it takes our time, it's not that important. And now if we look at the files, we have an output, and this is kind of a rendering. So this will be the front, and you can have a visual check if everything looks fine. Here we have also some solder line, some silkscreen line. Yeah, we can leave it. This is where the connector will be. We have the text looks fine. The soldering looks fine. You see also all the VRs are untented. This is what we want because this is a debug board. And on the back also there is some rendering with, and here you see, you've seen just version.revision.date. This is what is here, version.revision.date. And if we look here, it is filled automatically with the version at 0 because it's a prototype. 8 meaning that the board layout has been touched 8 times, or has a git commit 8 times. That's the hash, the git commit hash, and it's the date when we generated this output. So this is, yeah, always the date where it is generated. I don't set it. Oh, here, source, for example. Here, this is kind of annoying. This could be corrected. We won't correct it. It's fine. I think they will remove, I hope they will remove everything from the seal screen. So everything which is not open, which is not filled in solder mask, should be removed in the seal screen. And this, either you do it yourself or the fab house does it. And it's really important to check that because not all fab houses do it. And I used to have a footprint where this line, seal screen line, was over all the pads, and the fab house did not remove the seal screen, which is completely fine because you provide the seal screen, so you want it this way. And if you add seal screen here, they will add seal screen in the end. It was my fault. Some fab house know, okay, there should be no seal screen on the pads. We will remove it, and we will check if the fab house also removes the seal screen from these things. I hope they do, and they do a negative. We will see. So visual output seems nice. Now, don't just rely on the visual output. You also have to check the Gerber output. Important. This is what you will send to the manufacturer. So GerbView, I think, yeah, GerbView or GerbView. I don't remember which one I prefer. Yeah, enable hello acceleration. No, it's not this one. It's GerbV. So you can have different Gerb viewers because they all have different advantages. We add layers, IOVoodoo, hardware. These are all the layers. This. I think that's all. Yes, it is. Open. Yeah. So let's switch them all off. So somewhere there's the outline. GB, no, that's not outline. No. So the naming is always different. That's, I think, I don't know what G stands for. Gerber top silk? No, solder mask. Okay. Where's the outline? GTO? No, that's top. So let's check where the outline is. That's not it. Here. GKO. Okay. GKO is the board outline. That looks fine. Now, these are the holes. And they are plated and unplated holes are put together. For example, oh, there's an issue. You see, there should be, let's see if it's present on the routing, but this is the USB connector. On the USB connectors, we should have tabs for the USB connectors. We have the holes here for the two dimples. Here, we see we have these two holes, but we don't have this tab. This tab might be in another output, but we have to pay attention for that. Will it be somewhere or not? We have the two holes, we don't have the holes for the tabs. We have the outline. This is the top solder mask. Yes, that's the top solder mask. Then we have the top paste. We don't care about the paste. We have the top outline. This is the seal screen. Seal screen looks nice. Then we have the top layer. These are the copper tracers, and it is filled. So whatever we had in different colors, we had blue for ground, red for power. Everything is just yellow now. Then we have, these are the outline. This is the bottom solder mask. So the solder mask is open. Let's just keep the outline. The solder mask is open. This is the bottom seal screen, the bottom layer, and this is the assembly output. This is where the parts are. But we have an issue. We don't have the outputs. We don't have the output for the drills for the tabs. They are not here. They are not. Generally, they are in the drill file, and if they're not in the drill file, they're in the outline. They are in neither of them. So I have an issue with that. Is there some other device? AST, GPL, GPO, so we have all of them. GTP. Okay. Yes, XL. Don't have any other layer. This one, here is a message which said, here. There are some issues in the XLM, that's the drill file, the XLM drill file, and it says that it doesn't support all the things. It doesn't support N15, and these are probably the holes for the tabs. So this viewer does not support these commands for the drill file. See, it only supports drills. It seems it doesn't support tabs. Important to see the messages. Let's check the other one. Pair view. Do you support it? Your layers, open Gerber files. Technically, it's not a Gerber file. It's an excellent file. The drill files are excellent files. Hardware. And I think, yeah, I have to open Excel file here. Gerber files, this is for the seal screen, solder mask, and layers. Everything which is drill is Excel drill file. Hardware, URL, no, Excel drill file. Oh, wrong one. IOVoodoo. Hardware and XLN. I don't remember which output is GTO. I think so. This is just Gerber. Gerber normally is GBR, the output. But every fabrication house has their own rules. Often they comply to the output generation of. So you have to define how. Yeah. Whenever you generate output, you generate a lot of Gerber files, one per layer. So one for the seal screen, one for the solder mask, one for the copper. These are all Gerber files. They are often abbreviated GBR. The problem is if you have all the device ending with GBR, how do you define them? So every EDA tool has its own way of outputting the files so you can identify it. I think this is the not the KiCad, but the Eagle way to do it. And you can change it. So let's just open this device right here. File, when you export with cam job, you have plenty of cam jobs here. For example, Eagle. I also like this program because it has predefined cam job. And Eagle out does it this way. GLC PCB. I've exported GLC PCB. I could export Spark. They also use this same thing. You see, when it ends with GPO, it means it's the top silk. Same here. And PCBWay uses almost the same. No, not exactly. PCBWay have it in the name and not in the extension, which I find more correct actually. And yeah, and this is universal. This is with the name and the extension. And here you also have the name and then GPR, top silk, and so on. So every fab house have their own rules, and you can find up on the website what they prefer, the naming of their exports. I've just used JLC PCB because to use this fabrication, I'll tell you why afterwards. And here you see bottom screen, bottom mask. And excellent file. It's everything which is plated and unplated. So the drills, the U drill, so plated drill, unplated drill, plated routes and unplated routes. And the plated route and unplated route, this is where the tabs are. And I hope that GURB view has crashed. Open excellent file. I think GURB the hardware output is not really working nicely. So board.xln, yeah. Okay. And you see, it really depends on the program. If you only use GURB, which is simple to use, you don't have this slotted. At least it warns you, which is very good. GURB does show these slots D26, D26, D26. I think stands for diameter 26. But here we have the slotted. Here we have the slots for our connector. So this works nice. And we can also add all the other ones. For example, this one, I think this is the outline. The outline works fine. Here we have the bottom solder mask. It works fine. We can enable it. It looked way on GURB V. And GURB view was just to find out if we have the slots. So this is important. So once you've checked with once you've checked the output with your Gerber, once you've checked the output Gerber, then what I also do is it doesn't tell you if all my footprints are right. So let's quit this. Let's quit this. what I do is the schematic, we will need it later. This is a file. What I have as output is this. It's an overview with all pages of all the different things. Kill screen, solder mask. So here we see that we have the written normally here. Bottom silk, mirrored. Here we have the top with all the footprints. And I think I will print this one, but we'll check if there's no better one. Here, this one looks kind of nice. It is the top mask, but we will use this one. So it is in A4. We also have an overview. And this is a nice output. And this is the placement output, the assembly for the assembly. Top assembly, bottom assembly, we have nothing. What is this? Unplated drill. We have 2 unplated drill holes. Normally, the unplated drill holes are really separate files because in your drill file, excellent file, it doesn't tell you if it's plated or not. How does the manufacturer know if it's plated or not? Well, in professional manufacturing, you have 2 different files. One with the unplated holes and drills, and one with plated one. JLCPCB only wants one excellent file, so there's no way to specify plated and unplated. What they do is they check if there is copper. For example, here there is no ring around it on either side, so it means that this will not be plated. Here there is a ring on both sides because it's a via, so they will plate this one, and this is how they will make the difference. But you could perfectly have it is possible to have this plated without having any ring, or you want a ring but you don't want it plated because you want to have the 2 sides really separate. That's possible. For example, if you have board edges on the side where you connect a connector, and you have a hole still for mounting, and you have 2 pads on each side. The hole is just for mounting, it's not for connection. And you want the 2 pads on either side to be completely disconnected. There's no way on GLCPCB to do that except to add a node and hope that they read the node file and they don't plate your hole within the connections. Professional houses have different files. And here we see this is a different file, unplated. This is the paste, we don't care about the paste. This is the outline. Group 12, this thing which we don't use. So we will use, which output was it? Nope. We will use the solder mask outputs. This one, top mask, yeah, solder mask. We will print it. LaserJet, yes, print it here. Up, and what we will do is check if everything fits, because plenty of the footprints. Oh, that's weird. Printed nothing. Current page. Sorry. Print. The first page was empty. This is weird. My printer doesn't print anymore. Yes, here you see the pages are empty. I have no idea what's happening. Page setup. Long edge, that's okay. Portrait, that's okay. Color, yeah, it's black and white. Advanced, printer default, toner saving off. Printer density, none. I don't know why it's none. Let's have it maximum density. Current page, print. Nope, still nothing. Empty. Why doesn't my printer print? Maybe it doesn't support the PS file, so let's print to file, current page. PDF, printed as PDF. And printed. USB-C specification. Board. Oh. Oh. This is weird. It is really empty. But this is not empty. Why can't it print this page? Current page, print to file, PDF. Setup should be fine. Preview. Preview is empty. Oh. I wasn't aware that there's a PS which is visible but not printable. Then we have to convert this PS to PDF. I think PS to PDF. Yes, PS to PDF. IOVoodoo.board.ps to IOVoodoo.board.pdf. Now it should have converted it, and I will add this hardware IO board PDF. Let's check. Conversion works well. I have no idea what the issue is, but I have to modify that in my script so this works. EaserJet, current page, print. Let's hope it prints now. Okay, it prints. And you see, it's a tiny board. It looks huge on the screen, but in reality, it is quite tiny. Oh, I didn't expect it to be so tiny, but it's tiny. And this is the board. So now we will check, and this is the top. We will check if the parts fit. The parts actually for which I've never used a footprint, and there are plenty of them which I've never used a footprint, and some parts I don't have actually. Some I don't. Is it at scale? No, that's weird. It seems to be a bit too small. Let's check what's the size. It should be AM. It should, the size of the board should be 7.6 centimeters. No, this is 7 centimeters. Should be 7.6 centimeters. Means that the print is not correct. Let me add this page back in the printer, and we will try to have a correct print. And actually I can add the empty pages. So is the output just broken? It's hard to check on here. Properties, PDF, US letter. No, I don't want letter, that's why. Is the output of my PS letter? Properties, US letter. Okay. I also have a letter output. How do I change that? How do I do it in my script? Let's check in the scripts. Here. PS file. So PCB. Let's check if there's an output. Yes. Not what I wanted. XPS empty, but I want to help for it. Help. Not available. Come on. Help topic. Help. Sports. Gerber PS. This is the topic. Media type. I think this is where I specified it is A4. Let's try to do it by hand. PS. PS file, that's the PS. Media, can I specify A4 like this? Oh no, media option. A4 works this way. Okay, let's check if it's really A4 now. Properties, it is A4. Can I print it now, or do I still have to convert it to PDF? Current page, let's check. Why are you complaining? I hate my computer complaining, my printer complaining, because I have no direct, I cannot see the screen. Off. Jobs. Oh. Show all jobs. Show active jobs. Sorry. No, no active jobs. Ah, I know why it complained. The drawer to the paper wasn't closed. Let's try to print again. At some point it will work, I hope. And you see, checking takes a lot of time. Up. No, it didn't. It cannot print the PS. I have to modify the script so it outputs A4 because I'm in Europe and I print in A4, and I have to modify it so it outputs a PDF from the PS, and that's fast to do. That's okay. Now generate the PDF, and if we look at the PDF, that's the PDF. Properties, US letter. Huh? Oh, that's schematic, sorry. Board.pdf. Property, US letter. No. Why are you printing a US letter? The board is not US letter. Properties, that's A4. And PS to PDF. So, convert PostScript, the PS to PDF using GoScript. Yes. But I want to keep it A4. Okay, it's not written. PS to PDF A4. Convert per save page size. Yes. Nothing's better than this. Paper size. Ghost scripts. Let's try with this ghost scripts. Ghost trees is very dangerous. So we shouldn't. It's very dangerous. Yes, to PDF is safer. Oh, the difference. Let's try it this way. We'll see if it complains. Does not complain. That's a start. Does it do the job correctly? That's the PS version. PDF. A4. Print, let's hope it works. And which one is which one? I think it's this one. We'll check. That's not 7.6, that's 7.3. And this one is 7. Come on. Should be 7.6, shouldn't it? Let me check again. The dimensions of outline. 7.6. Ah. And this side, I'll check here. Delta 6.8. And this is 6.6. Why doesn't it export the correct size? Seems to be. If we fit the width. Page. Does it look this? No. Did shrink it. Shrink it a tiny bit. Why can't you print the PS? The PS is fine. Preview. Ooh, why can't I print the PS file? It another way. Let's open Genie, Inkscape. Apply imports. Although applies 9. So if we look at this line, millimeter 7.6, this looks fine. Let's try to print it this way. We don't need this anymore. That's for nodes. Laser jets. Print. Complained. Sorry, because size is not the correct one. Set. This letter. Who says this is letter? Document properties. This is not US letter. While when you import the PS, you think it's US letter. Properties. It says A4. But we will find it out. Do I have? Oh yeah, I do. Show jobs. No, show active jobs. Sorry. Why did Inkscape think this is a US letter? This is very weird. Let's put it to A4 and hope it works. It's printing. And let's check the print. 7.6. Ah, it is working. I'll fix off screen while the PS export doesn't work correctly, and then the PS to PDF. But for now, this is the output. So let's test everything. You get some connectors. This connector, this connector. Then I need some USB connectors. I think they're here. Yes, they're in this book. We need IC/MCU. We need the power, the capacitors, the LEDs. I know they work. The headers we have. Power protection, protectors, capacitors. I think it's in power. MOSFET, LED diode. Is it maybe? Let's check. So I have plenty of components which you don't see yet, but I'll put them one after the other. So we have first this connector, which should go around here this way, and you cannot see it, but the footprint matches. Yes, the footprint. Oh, I'll just leave it this way. The footprint matches. I could even have the board, the outline, but I think it's okay. What's the most important is where the holes are. So this connector matches. Now we do have IDC connectors here. This matches. Actually, we can see if there's enough space between the both of them. Yep. They match. We have this IDC connector, which is 2x4. 2x4, I don't have them. I have only 90 degree. Why don't I have 2x4 and not 90 degree? I have them somewhere else. It's just here for the footprint. Times 4, this works. So this connects, not the connector which we'll use, but the footprint is the same. Works. What's important is the 2x10 90 degree angle. That works, and also with the board outline, it's fine. It's not colliding. Next, let's continue with the connector, and let's try the USB connector. And I have some 16-pin USB. As I said, I didn't add them in my. So here I have plenty of USB connectors, and we will have the 16-pin. It's this one. Can actually already make a box with all the connectors. Neat. No, let's make it in the end. So 16P. Open somewhere. This one out. 16P connector. Mounted. The book open. USB-C 16P goes here. Fits nicely. Do all the pins fit? All the pads? Yes, they do fit nicely. Zoom a bit. Probably more interesting for you. Actually, let me switch completely. We can have bench. Yeah, this way. Well, you don't see my bench. Let me switch on the camera for the bench. This way you can see all the parts which we don't use anymore. So USB-C connector works. Let's put it back where it belongs. I could already make a box with all the parts which I need. Do that in the end. This way they are still ordered, and if I change my mind, I know where the parts are. So this is my SMD book. Damn it, with the connectors. It was loud. These were all the boxes. What else do we need to check? I don't need to check the the LED and so on, 0603, I've used them in previous project, they're fine. Schottky, TVS. Okay, it's not the correct parts, but it's the same footprint, the TVS diode. I only have one with 2 pins and in stock, and this one is with 6 pins. But the footprint for this part is the same. It's a SOT 26.3 and footprint works. So this is correct. I did. Oh, what's this? There's a part which is roaming around. Pretty sure it's one of these devices. Yeah. Put some tape. I don't have any tape anymore. Buy some roll of tape. It's USB-LC. Yes. You go here, and I need to find some tape. Let's use. Sure. Yeah, this one. This tape. It's annoying not having tape anymore. Happens. At least the desktop size one. I'll leave the tape here. Use it afterwards. Tape. Oh, this part doesn't fly away. I need to test the fuse. Where did I put the fuse? Voltage regulator, maybe? So this is the book for the diodes and so on here. This is the 12.6 part. This is the fuse which will go here. It fits. Yes, it fits. Yes, it fits. We wanted some LDO. I think we're using this LDO also. So we have two LDOs. We have one here, 1.8 volts, one here, 3.3 volts. As you can see from my parts, I only have the one with 3.3 volts. I have the one with 1.8, but they have the same footprint. They are just different parts. And I think I've used this one in a project already, so I shouldn't have to check. But either way, let's check. And SOT 23, 3 pins. And go the right way around. Yeah. SOT 23, 3 pins. Yes, it works. Yep. Put it back in the bag. Don't remember. There's lots of footprints I've corrected. Normally everything which is in my repository, which was in my repository before I checked it out for the project, should be fine. This is fine. Diode, and now we have the microcontroller and the clocks. Where do I have all the clocks? I think the clocks are in another bag in another box. They are in this box here. Here we have the surface mounts, 8 megahertz. Check if it fits. Megahertz surface mounts, yes. Plenty of space. What I was afraid of is that this doesn't fit. So I have some courtyards definition or keep out definitions for these parts. And these two capacitors were really close to it. But as you can see, this way. As you can see, there's still enough space between the capacitor and this thing, so you can fit the capacitor. Not an issue. So the clock works. And these are huge clocks, but I have plenty of them, which I want to get rid of. So let's make prototypes using this clock. That works. And now the microcontroller. I only have one of them. They're expensive. And this is just a prototype. More than one of them here. This is the one. And yeah, I also keep the moisture sensitive indicator here. So it's an ESD bag. There should be no ESD forming or going through it, and then the moisture bag will tell me if I need to bake the part or not. But I never had to bake the part. I'm not in a climate which is very humid. Still keep it for good measures. But I don't keep, so you see, when I order, I just cut the label and put the label here, or I write the label back again. But I don't keep the original bag or the tray or the tape because it takes too much space. And here, I think the pin 1 indication is here, and the part fits perfectly. Microcontroller fits, and if with all of that, all the rest are capacitors. Ah no, there's the SPI flash. I've never used SPI flash, and I have to pay attention because an SPI flash you have tons of different packages for SPI flash. Normal body width, large body width, and so on. So microcontroller book goes here. This goes here, and the SPI flash should be here. I have a bag full of them. Yeah, SPI flash costs nothing nowadays. Flash is very expensive within the microcontrollers, and you really pay a huge price. You want more flash for microcontroller, but external flash is not expensive at all. And the part fits. I don't remember, I think this was pin 1, but we don't care, I just want to test if the part fits. The part fits. So with that, all the part fit, and this step is really important because screwing up footprints is very easy to do, partly if you don't have the right parts. This is done. Check. See, we started 1.5 hours ago checking for if we can order things. We finished the routing, we finished the layout, the board layout, and we still are checking if everything is okay. But doing it now saves a lot of time afterwards. Let's go back. We don't need this. We've checked the footprints. They are fine. Well, the new footprints. All the other ones, I already know them. They should be fine. I'm sure there will still be a mistake somewhere. This never works the first time. But we can put all the chances on our side. So now that it is done, we need to make the bill of material. And the bill of material, how I do it. Normally you have a CSV file, and I do have a CSV file, but I generate my CSV file. For example, a break bomb. Now the CSV file is generated, and I have BOM, like bill of material, which says what is where, and I need to put a lot of documentation because this is not complete. What is complete is the reference designator, the quantity, and the device. Yeah, the device, they're right, and the values, these are right. All the other things are not complete, and the footprint, this is also right. All the other things are not complete. The description, this is where I put which part exactly I want to use. For example, if it's an LED, which kind of LED, if it's a crystal, and this is not, I always call them crystal resonators. They are not resonators. Resonators have an active circuit, so they have VCC and ground going to them. This doesn't. This has only 2 pins, so it's a quad crystal, and not a crystal resonator, and or not a crystal oscillator. Quad crystal only. Description. So how I do my bill of materials, I do it within the schematic. For example, this is already documented. If I edit, you see description, connector, USB, receptacle. They're called receptacles. They're the opposite to the plugs. 16P means 16 pins. This is a standard. Connector. You find it even in the USB specification. The footprint is defined, and you can, in the description, it tells you what the alternatives are. Any alternative corresponding to a USB receptacle with 16 pins and a matching footprint, you can use it. I don't care about really having the right manufacturer. I don't care about the quality of the connector. It's a one-off. Here I did provide a manufacturer and the manufacturer part ID. I even added LCSC ID because this is where I got mine from. But you could use any kind of alternative. This is just for a reference. It's not mandatory. Sometimes I will add, sometimes I will say you have to use exactly this part, but this will be in the description. So this is done here, for example. This connector header male 2.56 millimeter pitch 1.5 pin straight through hole. Same with this connector 2.5 and it's 2.4, it's not 2.5. I didn't provide any manufacturer, I didn't provide any LCSC ID because this is a jelly bean part. You find it. If the manufacturer has it, you can find it. But I do that also. I will do the manufacturing at my place, so I don't need at all to provide this information because I know the part I want. I don't have to communicate my bill of material to anyone else except me. But it's still a good practice to do it the correct way. So if you look at it in 10 years, although no one will look at it in 10 years, then you still have all the information. Here, connector header, 90 degrees. This part, for example, these have matching footprints, so it's a TVS diode with 4 data lines, and I designed it, so the most known brand probably is ST, but there are plenty of other manufacturers which do that. And for example, I don't have this part. I do have the one with 2 data lines, but not the one with 4 data lines. So I will need to order it. So let's order it. And this is now LCSC, L, USB, LC6, 4SC8. So I will order this prototype using GSC PCB because the quality is not too important. It's a very large board. There's no compact. The tolerances are not very great. And I wanted to show you, I needed some parts. For example, I don't have this part. And this allows me also to order the parts without paying for shipping. And there are not a lot of parts. I have to log in. About log in. Up. So here you see ST are the ones which do it most. For 5 of them you pay 15 cents. If you take some if you take some alternative vendors, they often comply to the specification. Here, this one, Tech Public, it's half the price. So I will use this because it is half the price. And yeah, if I buy hundreds, it is less than half the price, and they are in stock. So in this case, I will use this one. Add 100. We need 1, 2, 3, 4, 5. We need 5 per board. This is a Jelly Bean part. It costs less than 5 cents per part, so I always buy 500. This one, the deal, yeah, very good deal. It's still 9 cents per piece instead of 15, sure, for 100 piece, but here it's still 4 cents. So let's add it to the carts, and still, let's have a look at the data sheet. So here I don't need to provide the LCSC ID. That's the generating part. SOT 26.6, that's the same thing. And also this is also why I add the footprints. Where is it? Here. In my bill of materials, you see the footprint. This is most of the time it is a generated name here. And this corresponds to the IEC standards. Is it IEC? Which one is it? Let me open the standards. IPC, sorry. IPC, data, doc, electronics. Land pattern naming and land pattern naming convention, yes. Here. This document, IPC 7351, number revision B, this one. This gives this specification specifies how you can generate land patterns using dimensions of components. This is what KIDA is using, and this is the library I'm using for generating the footprints. And by generating the footprints, it also complies to this. Okay, PCB library has explained how this works, but there's a standard. And for example, capacitors, chip capacitors, or chip CAP-C, CAP-PC. We know it is the capacitor with body length, body width, and height. And if you look in my BOM, CAP-C, okay, so it's not exactly CAP-C. What does CAP-C means? CAP-C, capacitor, chip. Oh, it's correct, CAP-C. So it does comply. In the BOM, you have the footprint. This 1608, this is the metric version of 0603. 0603 is imperial. Same for the resistors, same for the SOT packages, SOP or SOTs. For example, we talked about this part. We are looking at this part, the USB LC6 SOTs. Then you have the pitch, then the package size, and then the number of leads. See, where's SOT? Here, SOT 23, SOT 23, SOT, pitch, lead span, nominal plus height, quantity of pins. So when I say, when I say matching footprint, it has to match this dimension, and you have the footprint information in the bill of material. So the manufacturer should know what he does. With matching footprint, I don't only mean that the land pattern matches. You also have to match the pin numbering. I don't have to specify that the manufacturer should know that if he doesn't use this part, he needs to use something which is completely pin compatible. And we have to check if this is the case. SOT 26, SOT 23, we have to check for the footprints, which is this one. We have to check for the pinouts. The pinout is the same. Let's get the original data sheets. This is the original. Let's put it on the side here. Here we have the pinouts. Let's have a look at this pinout, and we see it corresponds. It is completely compatible, and it is really, if the default standard is ST. If anyone wants to make profit and wants to be a competitor to this part, then it is in their interest to match the pins. It's not always the case. For example, for transistors, it's not always the case. Here, it's very often the case, and you see that the footprints and the pin diagram, they match. They both match. Now, what's important is the diagram. E needs to be 0.95, E 0.95. Okay, footprint matches. I could check also the lead span. E is 280. Is it the same here? Where is the package drawing? Package drawing should be around here. So here it's not big E, but it is, how do they call it? They don't. Ah, H. H in, it's between 2.6 and 3, and yes, same. E 2.8, it's in the middle. Package works, so we can use this alternative. And this is in our shopping carts. We have plenty of other things in shopping carts. We will have a look afterwards. So, and this is for all of them. Then we have, I think, they're not all defined. I didn't put them all because I wanted to show you how I do it. Description. Switch. Momentary button, 6mm, double pole, double throw, DPDT. Double throw, double pole, I never know. Double pole, double throw. Let's check. DPDT. Yes, DPDT. Double pole, double throw. That's correct. And I don't have to specify more. This is specification enough for the manufacturer to know what I mean. I could, for example, you could also add the height. I don't know which height I have on these buttons. You can also add the force. You can have plenty of specifications. I don't really care, particularly because it's just for me. I could add also one for reference. I have plenty of buttons in a box. Let me show you the box. Buttons, 6mm buttons. Here I have plenty of heights, 4mm high, 6mm high, plenty of heights. 6 times 6mm, this way it's less ambiguous. I have to edit it here. 6 times 6, and I don't want to specify the manufacturer. Jelly bean parts. Up. What else is important? The LED should not be visible. No. And the resistors, yes, I didn't specify. LED. LED. So the category, diode, the parts, LED, color, blue, and matching footprint. It's 0603. I can use any LED. I don't care. I don't care if it's clear. I don't care about the power efficiency. I don't care if it's diffused. Just an LED. Blue LED, and it's just for me. You can, yeah. If I want something specific, I will add more information, or I will put a part. That's done for the LED. Now this IC flash, SPI flash, matching footprints. I don't care about the size. Although I do care. Matching footprints. And it's always, you have to, I'll show it later. 1 megabyte. Write it big B. This is, let's be clear, bytes. So it doesn't, they don't think about megabit. And here I see you must have at least 1 megabyte. I do have, the one I have 4 megabytes, but this one is 1 megabyte. And the 32 here in the name means 32 megabits, so 4 megabytes. But this is big enough multi footprint. PI flash. Yes. What else do I have? I don't remember where I get from. I think I got a pack of 100 from AliExpress. This one, this is very important. This is the microcontroller, MCU. Equal to manufacturer parts. It means you have no choice. You have to pick exactly this manufacturer and this part. And the value is the parts. Manufacturer part. C value. You have no choice. I want exactly this one. No, I don't want pin compatible. I don't want any other size. I want this part. And I will specify which it is. Manufacturer. It is Cypress. Cypress is now part of Infineon, but I will still call it Cypress. And I think it is still sold as Cypress. MCU. We can add a bit more information. PSOC 5LP. And it's the 2044 series. This is just for information. Cypress up, and then manufacturer ID. This is the value. It's this one. So if I copy the manufacturer ID, that's correct. And then I bought it on DigiKey ID. Let's look at my parts. Test parts.IOVoodoo.info. Let's log in. Login. Microcontroller. This one. And distributor. DigiKey. This is the DigiKey part number. It? Well, yes, it should be. Let me check on the book. It seems rather short. Yeah. It's not, manufacturer parts. No, part number. It's not completely this one. It's somehow there's something missing. LP108 ND. And DigiKey ID. Okay, it's the same than the part, manufacturer part. And ID, ND stands for, I think, not detached or something like that, or not a tray. It's a loose part, I think. What ID stands for, or something like this. Close. Close this. Up. I can close this. The schematic. So this is defined here. This oscillator is not defined. Let's edit it. Description. Not an oscillator, just a quartz crystal. I always. It's a crystal. Quartz crystal. the footprint has another quartz crystal, and I can choose anything from 10 to 16 megahertz, and also yeah, often what you define is the ppm. Well, I don't care about the precision. It's like 10 ppm. I don't remember what I've ordered. Yeah, anything between 4 and 16 megahertz is accepted. And it is HC49 SU, something like that. That's the common name. So the footprint here defines how it is, but this is an alternative name for the footprint. I think this is the sheet. Now let me have a look at the data sheet. Where did I add it? Sure, I have the data sheet saved somewhere. No, I don't. Data connect IO. I see. Data. No, I don't have. There is another way. So we add this description. Oh, we can match footprints. If we look at VGKey, VGKey 8 megahertz. Put this on the side. Crystal. Yes, it is a crystal. It is not an oscillator. Although, why? There are plenty more oscillators. 24,000 oscillators, 10,000 crystals. Yeah, the oscillator. Although this is an oscillator, this is it. Check. Normally, an oscillator has only one clock pin, and oh yes, it is. Yeah, I have D, ground, and one clock pin output. It is an oscillator, not a quartz crystal. 8 megahertz. So this one here, there is here 18 picofarads. Yeah, that's the package. That's the very often, and I was right. So everything which fits here, and then what's important, what you could say, it's about the frequency stability or frequency tolerance. I could specify them here. They are all perfectly within the margin. They are better. So the 50 parts per million is better than the 1%, which is in the microcontroller. The microcontroller, so parts per million, 50 parts per million. A lot better than the 1%. Very stable. And even the worst one have something like this. So put anything which matches. I could add everything which is 100 parts per million, example. Less or equal than 100 parts per million. Plenty of space for everyone. I have to add it here. Yeah, 100 parts per million. And I didn't say if it's frequency or frequency tolerance or frequency stability. It's both of them. If you have more questions, you ask. If the manufacturer has more questions, he just contacts me. Jelly bean parts. So, magic. Let's continue with the parts. All the capacitors. and all the resistors. I think this is all that's remaining. Ah no, these are remaining. Voltage regulator. I can add like both of them, so it adds it to regulator. I have to differentiate. Voltage regulator, let's have for both of them. Voltage regulator, LDO, that's the type of voltage regulator. Then we have the outputs. Let's add 3.3 volts. Output is equal. Input is at least 6 volts. Output is equal to 3.3 volts. Output is at least 0.2 amp. Matching footprints. That's all I require, and add the description. But for this one, it is not 1.6 volts or 3.3 volts, it is 1 volts. .8 volts up, and I will order it from. I have the 3.3 volts we've seen from my SMD book. I have the 3.3 volts. I don't have the 1.8 volts. I think I already have it in my parts bin. Yes, this one. So I can add this one in LCSC. How many do I order? 120. Yeah, 120 is fine. Cost also nothing. Yeah, $3 for 120. CSC ID. This parts. And I can add the manufacturer part without. Let's check if there are other manufacturers of this part. Yes, there are at least 3. Torex, UMB, and I think the original is Torex. Tech Republic is also one of them. So we can add LCSC ID, manufacturer ID. This is most important for manufacturing ID. Match footprint, match manufacturer ID. Match manufacturer ID. And we have to add the manufacturer ID. Now, yeah. And yeah, this is the least expensive one. It's within the tolerance. I'm not doing rocket science. They're even cheaper. Oh, they're not cheaper. Another cheap. Why are they so cheap? Is it? Damn it. I can't understand. But here, output current. V out 3.3 volts? No. This is because this is the general data sheet, but it is not 3.3 volt output. We have 1.8 volts and version 2. Yeah, see? This is what you pay for. Quality of data sheet. No, we don't have 3.3 volts. V in is 4. This is just an example. If you have 4.3 volt input and 3.3 volt output, the maximum is this. But the maximum output is input is 0.8 is 5 volts. It's a bit more than 5 volts. And if you look V out, and always different. V in, that's the absolute maximum, exactly. We said everything above 6 volts. And this is the maximum, it's 9 volts. Out, that's the absolute maximum, 0.8 milliamps, 0.5 milliamps. I don't believe it. Ooh, They ask for 10 microfarad. I don't put a 10 microfarad. Put 1 microfarad. But yeah, the parts should be fine. This part should be okay. Quality of the drawing, amazing. Oof, it's kind of a JPEG. What do you expect for this price? So we have it in a thing. This one. It's called all. Now all the resistors. I don't think I have all the resistors, but let's specify them. Yeah. This 10K I have, 1K I have, that's for sure. What's really important is this one. This should be 1K exact, but we'll define it. 0 ohm. That's all of them, so we specify all at once. Edit the attributes. Description. Don't same. So resistor. Chip 0603. Less than 5% tolerance and 1/4 watts. And then everything which is like temperature coefficient, I don't really care. You could define them, but this is at least a 1/4 watts. Oh, do I have 1/4 watt or 8 watts? Let's check in my parts. This part, resistor, passive resistor. I'm sure there are some values I don't have. Yes, 4.1 I don't have. Do I have 0? 0 I do. I have plenty of them, but I don't. 22, do I have 22? I do have plenty of them. But since I didn't make anything USB-C, did I? No, I didn't do any USB-C device. I don't have the 5.1 value. We will have to order it. 0.1 watts. Okay, it's a tenth of a watt. And it's perfectly fine, a tenth of a watt. We will not put a lot of current. There will be a bit of current. There's 22. There's a 22 ohm which can sink 8 milliamps. 8. Yeah, it's still fine. Because if you do 8 divided by 20, 8 divided by 22, it's, oh no, it's not fine. It's what? Sorry. What? 8 volts. It's fine. 8 volts divided by 22 ohm. 0.3. No, it's 0.3. It's 8. 8 minus 3. We are, yeah, well below the 1 watt. Well below. We're at 0.0003 watts. We added to all of them, and we have to modify for. Do I have some of this? I think I do. 10%. Oh, I don't. I need to order it. I don't have a 1K 1%. This one. Let me check. Yeah. These one are voltage divider. Here there should be around 1.8 volts. Since it's the same batch, I expect it's the same. It doesn't have to be really that precise. But this one is very precise because I do a lot of calculation on that. This should be at least 1% precise. Oh, I have modified here. I this is used to calculate the external pull-up or pull-down resistor. So this needs to be precise. Do this one need to be precise too? It would be nice to be precise because it is a voltage divider. Do I have them? 10 kilo, 1%. Yes, I do. Let's define it this way. And the division here is 1.66666, which is fine. I don't know, 5%. If we change 5% for that, and there will be 5% here, so 10% deviation. Yeah, it's too much. So I have to set it to 1%. And no, this. I have to set it to 1%. Okay. And I need to make some orders. Yeah. 10 kilo. Ah no, 1 kilo. I do have 10 kilo at 1%. I don't have 1 kilo at 1%. Not diode, surface mount, chip resistors, yes. 0603, 1 kilo, 1%. In stock, apply. I want to sort the price. Yeah, all the same. Yeah, you see, yeah. I don't specify the ppm, it's not too important for me. It's a huge board, it will not be in a case, so it will be regulated. And I want 1,000 of them. 1,000, yeah. See the price, even if I buy 1,000, it's $1. Up, that's added. And I need also 5.1 resistance. 5.1K. Yes, this is for USB. The package 0603. 0603. Stock. The tolerance, I don't care. Oh, there are none. Fuck, no resistors. Discontinued. $5.1. What? I'm joking, right? Don't have any stock. Oh no, something wrong happened. Well, in stock 5.1K, one remaining. $5.1. Do I have really to order it somewhere else? Do I have some? Let me check. I do have a book of them. 06 here. 603. Do I have 5.1K? 10K. 5.1K. I do have some spare ones. But I'm really wondering that 5K1 maybe? Isn't this a jelly bean part? The first mount resistor. 5.1K. Okay. Now the plant, the package. 120606. Oh, they do here. Why isn't this one showing up? Yeah, LCSC. Very good. 0603. Have some stock? Yes, you have some. Wondering. We can close this now. Sort by price. And let's put 1,000. 1%. Yeah. Oh, 1% is cheaper than 5%, and yeah, 5% is fine for USB. For USB-C. Up. So this is added. I don't need 1,000, but at this price, it doesn't make a difference with 1,000 or 100. And I have enough for the rest of my life. And I can give them away. It's these ones, 5K1 ones. So normally they're all set. Now it's up to the capacitors. Let's select all the capacitors. Capacitors are a bit harder to specify. Oh, the fuse. I think I've set the fuse already. There's one capacitor here. Okay. And I don't specify the value because the value is specified value. Edit parts. Edit description. Description. Capacitor. MLCC, multi-layer ceramic capacitor. Better than minus 20% plus 80%. Most of them are now minus 20%. Let's check, for example. If I use 100 nanofarads. 100 nanofarads, multi-layer capacitor, SMT, this one's. No result found. Here we have 603. You see the normal minus 20, and then I always forget the rating, how it works. I need at least, yeah, so the voltage, it's at least twice the voltage it's needs to be used, simply because for ringing it will go higher voltage, and also because the multi-layer ceramic capacitors have a DC bias. When you have 100 nanofarad, 100 nanofarad is at a specific voltage. If you start to go above 50% of this voltage, the capacity drops really fast. This is why you need at least twice the voltage. I need at least 16 volts, and most of the time it's 50 volts. Yeah, you see, 15 volts. At least 16 volts. So it's 3 times the voltage. That's what I'm using. And then the rating, I think the minimum rating is X5R. I remember X7R and X5R, but I don't remember how the rating works. Capacitor rating. Capacitor rating. What does the voltage rating? Not X5R, for example. Yeah, all about circuits. Yeah, if you don't want to have this DC bias effect, you use C0G, and this means that they have almost no bias. It's a different compound. So the first characteristic, exactly. First characteristic is the lowest temperature handle. Yes, I think we can handle, yes, X is fine, minus 88 degrees. The second indicates the maximum temperature. 5 is fine, we don't need 6. 125, we don't do automotive. Our board will not go that high. And the last is the rating plus minus 5%. Starts R is the name. So yeah, X5R. C value and 0603. 603 C value. Add. And this is done for all the capacitors. Hope. Let's see. I think I missed this one. I missed this one. description. Add. Shouldn't be. What is those? Let's generate. Oh, we don't need this. We don't need this. I don't need this. Don't need this. My parts. Yeah, I have to check if I have all the parts afterwards. 0 ohm. What did I say? 0 ohm and 10k. 0 ohm I do have. 1k 1%. I didn't have 1k 1%. 1k. Resistor surface mounts. 1k. Everything up. 1%. 6 in stock. Apply. Up. Add. In the cards. I think I have all the missing parts. Let's check again. Let's make the, where is my generator here? Break bomb. Okay, this generates a bill of material. Let's have a look at the bill of material. Sheet, part, hardware, bill of material. Bill of material. They don't have all the descriptor. The test point doesn't have a descriptor. That's fine. The test point doesn't have a descriptor. It doesn't have a part number, and the footprint doesn't mean anything. And yeah, all the parts have a description. And if the manufacturer looks at it, it knows mostly what I meant. If he doesn't know, he can still ask me. For the most important parts, it is specified, and it's fine. Do I have all the parts? Capacitors, I have plenty of them. These values, I have plenty of them. This I don't, but we've added it in the cards. I have them, I have them, I have them, I have them. I have them, I have them, I have, no, we added, we have one R4. Why do I use 1K? What is R4? R4 here. Yes, it doesn't have to be 1K. I will change this value. I just added 1K, so it's not too bright. I don't know which value I will use. Probably 470, so it's not too important. But if we wanted to consolidate the parts, we would reuse the 1K part from here and then just have one 1K part. So we are fine. 10K, I do have 22. I do have, right? 22. I have 2 of them. Okay. Yeah, I have enough of them. 5% is fine. 0, I have this we've ordered. Push buttons, I have test points, nothing. This I have 1. This I have 100. This I have 100. This we've ordered. This I have 100. So we have all the parts. Quit. Now it's time to order the PCB. Discard all. Schematic is done. Did I change something? Yeah, I've changed something. I've changed the name. Before I order, let's commit all the things. And git commit -m part fix name. Git add git commit -m layout layout, improve sales screen location. Get status, ads, get commit minus m schematic complete BOM. Yep. And what did I hit? If yeah, this is what is exported. Git commit ticket add git commit break file fix BOM outputs. We need to fix the we still need to fix the PS output, but this is for later. And now break clean, let's remove everything and let's make everything again. It will take a bit of time. Yeah. And then we can order. Let me check while this is done. Let me check what else I have in my cards. So this we've added. So this is 1%, 5.11%. Care about the 1%. This is the TVS. Yeah, these connectors. I don't. Yeah, let's just only have 5 of them. That's expensive. I don't. This one is the vertical version. I need. This is the horizontal version. I need it. I have the vertical version. Good enough. This is the fixed output. Yes, this is fine. We have this already. Don't need it. Yeah, I don't have any surface mounts. Crystal resonator. Resonator? Resonator? Let me check. This is what I expect it is. So ground. Okay, 2 ground. So this is just are they called resonators? Quartz crystal. Okay, crystal resonator. SMD crystal. That's fine. So yes, I want some of them. 10 is fine for the prototypes. This is for another project. Touch IC. Let's keep only the cheap one. Right. SPI RAM. Yeah, I am missing some headers, so I want plenty of them. This is here. I do have enough of these headers. I don't want them. I have 10 of them, which is good enough. If I need a larger product batch, I'll order more. Yeah, these resistors, I don't have enough of them. I don't have these values. And back orders, yeah, I don't back ordered one. What is this? Yes, I want some points. So this is fine. Now, normally you should be finished with generation, yes, and then you should have generated the Gerbers and you should have created a zip with the Gerbers. So let's order glc PCB, add Gerber file, IOVoodoo, hardware, and then you have a zip. I love scripting, I don't have to do it by hand. And then we can check if it works. Upload the file. I am not signed in. Sign in. Sign in. The same account then for LCSC. Okay, now I am signed in. Stop waiting. Want to wait? What's amazing is that even 4 layers is now $2. No, 4 layers is not $2. I thought it was. Wasn't it? Wasn't it the The advertising they in the beginning with 4 layers is $2. Here, $2 for 1 layer, 1 to 4 layers, free assembly. Oh, I want to assemble by hand because I want to debug. Free assembly for your PCB order. And you don't have all the parts. But 2 layers? Ah no, starting at 5. Okay. This is very confusing. 1.4 layers, $2. That's not the case. Oh, I don't know how you upload failed. Uh-huh. Uh-huh. Analytics, TikTok. Seriously? Twitter, Google, live chat Inc. Okay, this is not something else. And we have tracking from Twitter, we have tracking from Google, we have tracking from Facebook, and now you've added TikTok also. Seriously? Who doesn't know I'm connected to you? What now? And maybe it doesn't work because one of the scripts, yes, this script needs to be allowed now. File manager, and Gerber. Okay. Gerber viewer. So I want to view it also with their Gerber to see if everything is fine. Yeah, we see that the holes, the slots, not just the holes for the USB connectors are there. So this is fine. We see that the solders is opening, the analysis results. Unrecognized Gerber file. Seriously? Gerber file with a board layout. Okay, so this we recognize. Not critical Gerber file. Yes, this is the assembly. But this is not a Gerber file. This is a drill file. Minimum drill, that's okay. Layer 2 with, okay. And since it is black, you know exactly where the drills are. And this is the top. Let's look at the bottom to see if the seal screen is here. Yes, it is. So the Gerber is okay. We want 2 layers. Yes, this is the auto-detected quantity. Yeah, 5 is plenty. I will use only one. I only have one microcontroller. I will probably use a second one for reference. Different design, it's one design. Let's see if they can play or not. It is one design. Thickness, normally the thickness is 1.6 millimeters. I want 1 millimeter for 2 reasons. I will cut this using a guillotine cutter, and 1 millimeter is a lot easier to cut. 1 millimeter is still rigid enough for all the components, and 1 millimeter allows me to solder this USB connector correctly, because if you look at the USB connector datasheet connector, you see that the leads here we have 4.2 minus 3.1 or 3.2. We have only 1 millimeter connector. So if it be 1.6, I wouldn't have any chance to solder these connectors correctly. This is why 1 millimeter is fine. Green, yeah, green is faster. It's the fastest turnaround. And I like green because the solder mask is very robust on green. On white, the solder mask is not very robust. Hassle, yes, I have no need for ENIG on lead-free. No lead-free because this is not production, so I don't ship it to customers, so lead is fine. ENIG, I don't need. ENIG is a bit harder to solder, but it's very flat. I don't have any component which needs to be very flat, something like a QFN or BGA. For BGA, you have to do ENIG for BGA. Outer, yes, this is fine. Goldfingers, no. Confirm production file. What is this? Create production requirements? No, I don't need production. Create production contract. The option has been chosen. Checking production and configuration. I didn't know this option. Do I want to continue? It looks nice. There's nothing which is really hard on this product. As fast as you can. Flying probes, yes. Fully tested. Castellated holes, no. Remove order number. Ah, yes, I forgot about that. I can add, I can specify the order. Else they will do it for me. 1, 2, 3, 4. Let's put it somewhere where it is not annoying us, and this will be somewhere on this board on bottom. Here, JLC, J up, JLC, JLC, JLC. Okay, let's make it smaller. Although, what was the size? I don't remember. Click here for detailed information. Line width 1.15. This is what I have, 15 mil, so that's fine. Put it somewhere where it doesn't annoy us. We will put it here. In this corner, or shall we put it under this connector? Oh, we can put it on the connector. That's nice, because once the connector is soldered, we won't see it again. So let's go to the top silk. Let's switch and let's put it under this connector. Text JLC, 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 JLC. Okay. F9 rotated. So it will be under this connector and we won't see it again. 1, 2, 3, 4. Let's save it and let's regenerate it. Here. Git status, git add. No, I want to. No, I just want to regenerate it. I don't want it to be in my commits. Rake. So it will take a bit of time to generate. Can I upload a new Gerber? Back to upload file. Yes. And the settings, do they keep the settings? No, don't keep the settings. That's very good. Professional. This. Bit of time to generate. Also have a look at the output. I will only check the rendering and not the Gerber output, because we've already checked the Gerber output for all the rest. Rest is pretty fast. So let's have a look. Bottom, that's the top. Yes, it is under the connector. That's fine. It's okay. Load Gerber. Load the new zip. Correct format? Did I? I probably selected something else. Does this still work? Yeah, audio still works. Okay. So again, 2 layers. Yes, quantity 5 design. We have only one design. We have thankfully talented. Save to cards. Let's add it to the cards. Check out. So now I will not show you on the stream how I pay or where I ship. If you want my address and if you want to ship me things, you can find it on my website, but at least I don't show you my pay credentials. So I will order it and I will be back. See you. Intermission. And we are back. So the order is here. It's been paid. And now it is in the review process. And I hope that the reviewer doesn't see and doesn't complain that there are two separate copper planes and thinks that this is two design in one, just a two-part design. So this is done, and now what I can do is order from LCSC, order, secure checkout. So again, here we have all the components, and I will again not show you my address and how I pay, but I just ordered this part. Is nothing particular, and I will tell you if I managed to have and not pay for the shipping because I have an order finished, because I have a PCB order. Let's test that. up, and here we are. And we've seen I've made an order, it is paid, and this is the price. And the shipping was not, so it is reduced because you've ordered PCBs. Everything is at reduced price, and there was a free shipping, and I used the free shipping. It will take 8 days to 20 days to arrive. The PCB will take 8 days to 15 days to arrive, something like that. So I have plenty of time. And until then, the project is done. I could continue working on the firmware because I still have this development board. The camera on? No. I still have this development board, which is perfectly fine for continuing developments and for SPI and things like that. But I don't expect that we will meet about the IO, or I will not expect making a stream about the IOVoodoo until I received all the parts and all the boards. And so the next stream will probably be in 2 weeks. Well, the next stream about the IOVoodoo, there will be other streams about other things meanwhile, and I will have a tiny bit of rest about this project, which is also nice. So it's done. The ordering, what we wanted to do today. Vim IOVoodoo XT ordering done. I've done the ordering. We just have to wait and then check the orders and solder everything together. So see you for the next stream for the IOVoodoo or the next stream in general. And enjoy the rest of the day.